আজকে যে টপিকটা নিয়ে আমরা ডিসকাস করব সেটা হলো ইলাস্টিসিটি। এই ইলাস্টিসিটি টপিকটা নিয়ে আজকে আমরা ডিসকাস করব। এবার ফার্স্ট কোশ্চেন হলো এই ইলাস্টিসিটি ব্যাপারটা কি? ইলাস্টিসিটি refers to the tendency to oppose deformations being produced in an object. যে ডিফরমেশন প্রডিউস হচ্ছে একটা অবজেক্টকে ফোর্স দেওয়ার জন্য, সেই ডিফরমেশনটাকে অপোজ করার নামই হলো ইলাস্টিসিটি। নাও obviously steel is difficult to deform relative to rubber. That means steel is more elastic than rubber. Now there are two main terms related to elasticity. First one is stress and another one is strain. Stress means force or reaction force produced per unit area. That is stress. And strain means the ratio of change in dimension and original dimension. মানে ফোর্স দেওয়ার জন্য যে অ্যামাউন্ট অফ চেঞ্জ হচ্ছে কোনো একটা বডিতে, সেটা ভলিউম হোক কি লেন্থ হোক কি এরিয়া হোক, সেটা আর অরিজিনালি যে ডাইমেনশনটা ছিল, অরিজিনাল যে লেন্থ অর এরিয়া অর ভলিউম ছিল, সেটার রেশিওটা হচ্ছে গিয়ে স্ট্রেন। নাও there are two types of stress and strain. First one is longitudinal stress and longitudinal strain. Another one is tangential stress and tangential strain. So longitudinal stress or longitudinal strain. There are two types of longitudinal stress and strain. First one is tensile and another one is compressive. Tensile means, consider here is a body of length L. Let F amount of force is acting on the body. Therefore, the body elongates by an amount of delta L. And compressive means, suppose this is a body having length L. Due to the applied force F, let compression in the body that equals to delta L. So longitudinal stress is F perpendicular by area. That means component of applied force perpendicular to the cross section divided by surface area of cross section. This is longitudinal stress, and longitudinal strain is change in length and original length, the ratio of change in length and original length, that is longitudinal strain. Now move to shearing or tangential stress and strain. Consider here is an object. The bottom portion of the object is fixed by the application of force F. Let deformation in the object. Let deformation in the object that equals to delta x, and change in angle that equals to suppose theta. So here the tangential stress is the ratio of F parallel and area, component of applied force which is parallel to the surface, and surface area, and tangential strain that equals to, here suppose the length is h, tangential strain that equals to x by h or equals to tan theta. This is longitudinal stress or strain, and this is shearing or tangential stress or strain. Now next move to bulk stress and strain. Bulk stress strain. When an object is subjected to deforming forces from all sides equally, the object is said to be under bulk stress. This can happen only in case an object is inside a liquid. In such case, the change in pressure itself is the bulk stress. That means bulk stress equals to delta P, change in pressure, and bulk strain that equals to minus of delta V by V, change in volume by original volume. Negative sign indicates that volume is decreasing. Now move to relation between stress and strain. To show the relation between stress and strain, let draw a graph between stress and strain. Here is point O origin. First of all, up to point A, stress is directly proportional to strain. This B point is elastic limit. Elastic limit মানে যতটা অবধি বডিটা ইলাস্টিসিটি ফেনোমেনাটা হোল্ড করতে পারবে, এই এতটা হলো ইলাস্টিক রিজিয়ন। অ্যান্ড আফটার দ্যাট, এরপরে দ্য বডি বিকাম প্লাস্টিক। দ্যাট মিন্স এই বিসি রিজিয়নটা ইন্ডিকেট করবে দিস ইজ প্লাস্টিক রিজিয়ন। And remember that breaking stress for a material is its property, which is not dependent upon the dimension of the object. Breaking stress is not dependent upon the dimension of the object, and this is the stress strain graph. And within elastic limit, stress is directly proportional to strain, and that is known as Hooke's law. Now move to Young's modulus. Young's modulus is the ratio of longitudinal stress and longitudinal strain. Another is shear modulus, which is denoted by eta. That is the ratio of shearing stress and shearing strain. Another is bulk modulus, that is denoted by B. This is the ratio of bulk stress and bulk strain. If pressure increases, volume decreases, hence delta P by delta V less than 0. Hence, to keep B greater than 0, negative is included. Now, the reciprocal of bulk modulus is known as compressibility. Reciprocal of bulk modulus is known as compressibility. Now, here is bulk modulus of gas for some standard process. For isothermal process, for iso now for isothermal process, bulk modulus that equals to P. Bulk modulus for isothermal process known as isothermal elasticity of the gas. For isochoric process, bulk modulus equals to infinity. For isobaric process, bulk modulus equals to 0. As in isochoric process, volume is constant, and in isobaric process, pressure is constant. In adiabatic process, bulk modulus equals to gamma into P, and in polytropic process, in polytropic process, bulk modulus that equals to N into P. Here gamma is the ratio of Cp and Cv. Next, move to thermal stress and strain. Here for thermal stress and strain, L equals to L0 into 1 plus alpha into del theta, where L0 is initial length of the body, L is change, new length of the body after the change in temperature is del theta, and alpha is coefficient of linear expansion. Here the thermal strain, that equals to L minus L0 by L0, that equals to alpha into del theta, and the thermal stress that equals to Y into strain. Y means Young's modulus, that means Y into alpha into del theta. This is all about elasticity. Now we discuss about some problems related to elasticity. Consider here is stress strain graph for two materials or for a material at temperature T1 and T2. তোমাকে বলা আছে which temperature is higher, T1 greater না T2 greater. তো heating makes deformation easier, which means lesser elasticity. Hence, at the higher temperature, elasticity and hence slope is less. That means T1 is greater than T2.